We're going to look at dividing polynomials using synthetic division. Synthetic division does a similar process as long division, but it's a little bit easier. What we do is we replace the x's with just their coefficients. So x cubed is 1, negative 2x squared is negative 2, negative 7x is negative 7, and 8 is 8. Now, what we're going to do is we're going to figure out what gives us a 0 right here. So we set it equal to 0, and we see that x is 5. So what we're going to do is we're going to divide this by 5. Synthetic division, what it's doing is it's finding the zeros of a polynomial where it crosses the x-axis. That's why we're trying to figure out what gives us a 0 for x minus 5. Now, our first step for synthetic division is bring the first number down. Then we go 5 times 1, which is 5. We add them. We get 3. 5 times 3 is 15. Negative 7 plus 15 is 8. 5 times 8 is 40. So we get 48. This right here is our remainder. So that means our answer, what we do is we just subtract the degree, and we have x squared for the 1. We have 3x for the 3. The 8 is 8. And then we have plus 48 over x minus 5. And that right there is our answer. So if we're looking at the next one, we're going to replace the 4x to the fourth with a 4. Notice that there's no x cubed, so we're going to put a 0 as a placeholder, just like long division. We have negative 9, we have negative 8, we have negative 2. What gives us a 0 right here is we subtract the 1, divide by 2, so negative 1/2 is what we're going to use for the synthetic division. We bring down the 4. Negative 1/2 of 4 is negative 2. Gives us negative 2. Times negative 1/2 is positive 1. Negative 8. Negative 1/2 times negative 8 is 4. This gives us negative 4. Negative 1/2 times negative 4 is 2. And that's 0. So it goes in evenly. Now, one of the problems with synthetic division is that when we have a leading coefficient like a 2, it doesn't divide the 2. So do you see that all the terms are even? Because of this 2 right here, notice that this was just a 1. So if we divide it by 1, it doesn't change it. But because of the 2, we're going to divide each of these by 2 before we write our polynomial. So what we have is 2x to the third minus 1x squared, or just x squared, minus 4x minus 2. And that right there is our polynomial. Kind of a difficult one. So if we're looking at the next one, notice that we have degree 4. We don't have a degree 3. 2, 10, negative 4. We're trying to see what gives us a 0, and that would be negative 2. So we're going to divide it by negative 2. We bring down the 1, times it, add it, times it, add it, multiply, and we get 4. It goes in evenly again. So we get x cubed minus 2x squared. Remember, these are the coefficients, plus 6x minus 2. Now, if we're looking at letter D, we have 27, we have negative 27, we have 9, we have negative 1. Remember, we're trying to figure out what gives us a 0. We add the 1, divide by 3, so it's 1/3. First one we always bring down, multiply by a third. We get Negative 18. Multiply by a third gives us negative 6. Gives us 3. Multiply by a third, that gives us 1. And it goes in evenly. Remember, because of the 3 right here, we're going to divide each of these by 3. So we get 9x squared minus 6x plus 1.